Got the common functions, or you guys can call these mother functions, or you guys can call these what mother functions, common functions? Oh, parent functions. Okay. Now you guys have to be familiar with the way each of these look. So, look at the way you write it, and look at the shape of the graph. All right, these are all important to know. Okay, so know them. Now I want to write the way they would look if there's shifts done to them, if there's some transformations done. So, generally speaking, let's say that f is your common function. Okay, if there's stuff happening to your common function, this is the kind of stuff that can happen. You can have an h subtracting from the x, and that would move the function horizontally. This would move the function horizontally. It's a horizontal shift. So we'll call it a horiz shift. And then you could have something multiplying to that x. Now that's very rare. This b right here, he is very rare. You rarely see a b multiplying to the x, but it does happen. And then so you have this function right here. And then sometimes there's an a multiplying to that function. And then sometimes there's a k adding to that function. This one is a vertical shift. We'll call him a verti. All right. Now the a, that one changes the way the graph looks. Like it stretches it or compresses it. Same thing with the b. It stretches or compresses. A and b also have the power to reflect the function. So like just straight up flip it. So like for example, you guys see this function right here. If this function, if f of x had a negative in front of it. Actually, I probably shouldn't call it f of x. I should probably call it something different just for this graph right here. We'll call him the g function. So if there's a negative in front, that would be a -1 for the a. This graph would not look like that. It would look like this. It would reflect it over the x-axis, and that's how it would look. You guys see that? Yeah? Yeah? Now, if I were to translate this stuff into the absolute value function, this is how it would look. It would be f of x equals x minus h. Oh. And then we put the b right there, absolute value. The a is out in front, and then you have your plus k out in front, or out at the end. All right, that's a lot of stuff right here. And normally not all of it is happening at the same time. And remember, b is irregular. We don't see him that often. So it's most important for you guys to know what the h does, what the k does, and what the a does. Let's talk about this h right here with the square root function. For this square root function, if I had an h in there, so like let's say it looked like this, then this would move this function to the right too. That's kind of weird, huh? Because you see minus and you would think to the left, wouldn't you? But it's not. So it goes the opposite way. And the best way for me to conceptually explain that to you guys is to make a table with it. But I'm not going to right now. We can do that later. So if there's an h in there, that would move this function over to the right. If I had a k there, like let's say just +1, then that would move my function up with the shift to the right. So we had a shift to the right and up if we had a -2 and a +1. Does this make sense to y'all? Yeah? Yeah? Okay, well what would happen if we had like a 3 right here? That 3 would stretch the function. So like if it's right here and this is the next point actually would be up here now. Not exactly, but I'm just like trying to show you guys. You see how it's stretched? That's a vertical stretch right there because that 3. If that 3 was not a 3 and let's say it was a fraction, like it was a number between 0 and 1, then that would compress it. So instead of it going up, the point would go down a little bit and it would compress the function a little bit and make it a little bit more straight. So anyways, for the absolute value function, it kind of looks like this. Like so f would have all the changes happening to it. It would look like, let's see, we have x minus h. And it's minus because we always think opposite there. you have the b, which doesn't happen that often, but we've got to recognize him. You have this a out in front, and then you finally have the k. So you have the hk, the a, and the b. And we can write all of these functions in a similar fashion. X minus h times b, square that dude, plus the k. A is out in front. Here's another function. Here's another mother function right here with stuff happening to him. I'm not going to do the cube just because it looks exactly the same as the quadratic. You just have to change this 2 to a 3. This one looks kind of weird. So let's do the reciprocal function. It would be with the x minus h on the bottom, and sometimes there's a b. The a would be multiplying to it, but normally you'd see the a up by the 1 because you would put a 1 underneath this a, and then you'd multiply it straight across. So let's rewrite it. Let's put a up top, then we have b on the bottom, multiplying the x minus h, and then you have your k. Whoa, look at all this stuff. All right, so we have f of x. There you go. And then we finally have our, they call it the greatest integer function. I call it the floor function or the round down function. So any decimal that you get, you got to round down to the nearest integer. That's the nearest non-decimal. The way this one would look is, let's see, we got to have these funky brackets right here. And inside these funky brackets, we have a b multiplying to an x minus h. And then we have the other funky brackets, and you have your plus k out there and an a out in front. So all of these, you got to get used to seeing. So when you guys see other graphs, you can pick out what those numbers are. And that's what you guys got to do with your practice. So while a and b are both like doing multiplying, okay? So like a is going to multiply to whatever you get after you do absolute values right here. B is multiplying to the x. Then you would end up doing the absolute values. So if you guys are ever changing points with transformations, if there's a b, that's changing the x's. If you have an a, that is changing the y values. And then you add the k to the y values. Oh, that's another thing. The h changes the x's, and the k changes the y values. So if it's inside with the x, it's changing the x values. If it's outside, then that's changing the y values.